Today, lack of agricultural land and devastating climate change have caused serious food crises all over the world. As the problems in agriculture progress, urban and indoor farming would be a key to a solution.
Hi, I'm Yoko Suzuki, an exchange student from Japan. I'm an agriculture and natural resources major at the University of Delaware. This summer, I'm doing research in Delaware Indoor Agricultural Lab, called DL, under Dr. Meng, who is an expert of controlled environmental agriculture and urban horticulture.
DL also focuses on hydroponics, a plant production technique that does not use soil, rather water mixed with nutrients alone, with or without addition of soilless media. This technology is also effective for urban agriculture and could reduce land use significantly. Our lab has experimented different types of plants and found interesting results. One of the research is conducted on lettuce and how we can control the calcium deficiency disorder called tip-burn. Tip-burn represents lack of enough calcium within growing leaves, and it has significant impact on the quality and quantity of vegetable production. However, through the previous research, they found out that with addition of certain amounts of biostimulant, plants can grow well and avoid the disorder. Based on the result of the previous research, I did an experiment to determine whether a chemical biostimulant works to control calcium deficiency symptoms in 4 plant species, which include lettuce, arugula, kale, and pak choi in Fisher greenhouse. We set the hypothesis that a chemical biostimulant will be effective to reduce the severity of calcium deficiency symptoms in all crops. In the beginning, I sowed 400 seeds in the rock wool cubes, and they grew well indoors in controlled environment. Then in the greenhouse, we set 12 trays, each with 90 liters of nutrient solution, added biostimulant to half of the trays, and placed 2 air discs to oxygenate the nutrient solution. After about 2 weeks, I transplanted seedlings to the greenhouse for further growth and development, and observed the difference then. During the experiment, I adjusted pH to around 5.8 of each tray on a daily basis to make sure of stable and constant nutrient availability. Plants started to show interesting differences between those grown with biostimulant and those not. Lettuce plants grown without biostimulant had higher tip-burn rate, while lettuce plants grown with biostimulant had decreased rates of tip-burn. Arugula plants grown without biostimulant had leaf edge burn, which is another type of tip-burn, while those grown with biostimulant did not have any tip-burn but had other issues which resulted into yellowish and pinkish color. That means the biostimulant concentration was too high for the arugula. For kale plants, those grown without biostimulant had bigger and greener leaves, while those grown with biostimulant had smaller and pale leaves. Finally, pak choi plants grown without biostimulants were bigger but had tip-burn, while those grown with biostimulant were smaller but without tip-burn. Therefore, we must identify the biostimulant concentration for each crops that is high enough to control tip-burn but low enough to avoid any growth reduction or disorders. If we could produce many types of healthier plants, it would be tremendous progress for sustainable agriculture, even in urban areas. I sincerely appreciate for this precious opportunity and every support for my experiment. Thank you so much.